See, today we will start reflection of light with the principle of Huygens. See, I have told in previous lecture Huygens principle. What Huygens principle? They have given a principle for construction of wavefront, and we also finded the plane wavefront, spherical wavefront, cylindrical wavefront. What are the Huygens principle? Huygens has said that each and every point of a wavefront, it will behave like a secondary source, and they will emit wavelets in all possible direction which travels with the speed of light in that medium. Second, they have said that new wavefront, how can we obtain? We have to draw envelope on the wavelets in forward direction, because they have said the backward direction in envelopes are ineffective. So by the help of Huygens principle, Huygens has explained the reflection. So today we will discuss about the reflection. I have taken a mirror, and yesterday I have told you about the plane wavefront. So like that we have made this is primary, so this is secondary plane wavefront. New wavefront of this is this. So like that, and spherical wavefront also I have explained. This type of spherical wavefront. The perpendicular upon this is the direction of ray. Here the direction of ray is like that. This I have explained previous lecture. Today we will discuss about the reflection of light from the plane surface. So see here what we have considered. Let us consider a plane wavefront AB. I have taken a plane wavefront AB. Suppose this previous is A dash B dash. Again it will come. This is suppose primary wavefront. So this is new wavefront. Again new wavefront will form. Then let us consider a plane wavefront AB perpendicular to plane of paper. This is plane of paper. I have taken incident angle I. What is the angle? This angle is I. Incident angle I have taken I. With the normal to the plane reflecting. This is the plane reflecting. This is reflecting surface, which is also perpendicular to plane of paper. This is like that. This will be the mirror. So this mirror is perpendicular to plane of paper. Let incident wavefront AB. This is incident wavefront AB touches the reflecting surface at a t is equal to 0. So this plane wavefront is coming perpendicular to this will be the direction of ray. When these plane wavefronts touching the reflecting surface, it is point A at t is equal to 0 time. At t is equal to 0, what I have considered, the plane wavefront touching point is A. And point B will touch the mirror. This point B will touch the mirror in time t is equal to t. After time t, it will touch the mirror at this I have point taken C. At point C. So from here to here, time taken is capital T. Capital T. Different point of wavefront. B will reach at C at time t. A will touch at t is equal to 0. So between A and B, all points will touch the mirror between 0 to t. For new wavefront, by the Huygens principle, what we have to do? We have to make hemisphere. From here to here, we have to make hemispherical wavelets. And if we draw envelopes, that envelopes show the new wavefront. So see here, from B to C, it will reach in time t. What will be the distance between B and C? Let V is velocity of light in given medium. If v is velocity of light, so what is the distance vc? Velocity of light v time t. So distance bc is equal to what? V into t. Same way, A will act as a new source. The in time t, what will be the radius of hemispherical wavelets? The radius of hemispherical wavelets, radius is equal to what? Velocity is v, time is t. So we have to draw a hemisphere of radius vt. So draw a hemisphere. So I have drawn a hemisphere like that. A hemisphere we have drawn. It will touch here. So this will be the hemisphere. When we want to find the new wavefront, we have to draw envelope. Envelope means touching surface. So from C will be at 0 radius. Between A and C they will reach. They have radius between 0 and Vt. What will be the tangential surface? So if I have drawn a tangent from here, this will be the tangential surface. This is the tangential surface from C to touching this hemisphere. Let this point is D. So this CD will be the new wavefront for given AB. Perpendicular to this, if we draw a line and perpendicular to this, so again they will emit hemisphere, again they will reach, again this type of plane wavefront will form. This is C dash, D dash, C double D, D dash, like that it will further move. So see here, this AB is initial wavefront. By the Huygens principle, this CD will be the new wavefront of AB after reflection. This BC distance will be, I have told BC is equal to VT, and we have drawn a hemisphere of radius VT. So you can say this AD is equal to radius, VT is equal to AD. So see here, there are two triangles. This ray of light, this is the incident ray, so this will be the reflected ray. Same way incident ray, this will be the reflected ray. I have told earlier, if a line drawn perpendicular to wavefront, that will be the direction of ray. So this will the perpendicular upon the wavefront. So this will be the direction of reflected ray. So this is incident ray, this is reflected ray. See here, angle between this is how much? 90 degree. Also you will see here, this is the wavefront, this is the direction of the ray, this is also 90 degree. See here, AD is equal to what? VT, and BC is also equal to VT. If you are taking this two triangle, ADC and ABC, see here, this is incident ray, this is normal. So this is the angle of incidence. Incident ray, this is reflected ray. So this will be the angle of reflection. Suppose this I have taken N, so angle A dash A N is equal to how much? I, angle of incidence. Angle NAD, this is angle of reflection, this is R. See here, this is I. What will be this angle? From here to here, यहाँ से यहाँ तक देखें, तो A dash A perpendicular to AB, so this total angle is 90, so this is 90 minus I. See here, this angle is 90 minus I. This perpendicular to this, so this angle becomes what? I. ये थोड़ा सा ध्यान देना यहाँ पर, ये काफी important है. अगर आप यहाँ पर ध्यान से देखेंगे, if you will see here, so this is angle of this is angle I, and this reflecting surface they are making 90 degree, and also this is reflected rays, total angle 90, so this is 90 minus I. and if this is 90 minus total 90, so this angle becomes I. So from the geometry, if we'll see, the angle BAC is equal to I. Same way, see here, this is R. The total, this is what? Angle DAC. Angle NAD. Angle NAD is equal to R. NA perpendicular to AC. That's why angle DAC. Angle DAC is equal to 90 minus R. So this angle DCA, this becomes R, because this is 90, this is 90 minus I, तो this angle becomes R. तो अगर ध्यान से आप देखेंगे तो एंगल BAC is equal to I, angle DCA is equal to R. So if you are taking this two triangle, I am taking this two triangle. One triangle I have taken, triangle DAC and triangle BCA. See here, this is 90-90 right angle triangle. Angle ADC is equal to angle ABC 90 degree. Next, DA is equal to BC. DA is equal to BC. Both are VT, velocity into time, and AC is the common. Hypotenuse AC is equal to CA, common. In right angle triangle, if hypotenuse and one side are equal, so they are congruent to each other. Mean triangle DAC congruent triangle BCA. So for congruent triangle, CPCT, congruent part of congruent triangle, so by CPCT what you will say, angles are same, that mean angle DCA is equal to angle BAC. So DCA I have shown here R, and BAC, that is I. So we have proved here I is equal to R. So by Huygens principle they have proved I is equal to R, mean angle of incidence is equal to angle of reflection. Second thing, वहाँ पर आप लोगों ने पढ़ा होगा, there are two laws of reflection. One is what? Angle of incidence is equal to angle of reflection, and another is that incident ray, reflected ray and normal all lie in the same plane. So from the figure you can see here, this is the incident ray, this lie in the plane of paper, reflected ray also lies in plane of paper, and AN is also lies in plane of paper. So second law also you can say, second law or first law, whatever you will say. So angle incident ray, normal at the point of incident, and reflected ray all lies in the same plane. और एक चीज और भी कह सकते हो आप कि incident ray and reflected ray both are reverse from the reverse direction from the normal. दोनों नॉर्मल की क्या है, अपोजिट साइड लाई कर रहे हैं. तो ये आप टोटल आप देख सकते हो कि यहाँ लॉज ऑफ रिफ्लेक्शन को उन्होंने क्या किया बेटा, विद द हेल्प ऑफ हाइजेन प्रिंसिपल, by construction of Huygens wavefront we can prove both laws of reflection. एक चीज और भी यहाँ पर ध्यान से अगर आप देखो तो AB is incident wavefront. After reflection, DC will be the new wavefront, and DC proceed D dash, C dash, D double dash. Same way here A double dash, B dash. ऐसे ही आपका एक और भी wavefront अगर हम करें A double dash, B double dash. So this plane wavefront is coming from the object. जो plane wavefront से कहाँ से आ रहा है, object. तो we can say that this will be the length of object. ये जो plane wavefront होगा, this will show the length of object. Same way, if you'll see this emerging या reflecting wave front, if we'll see here plane wave front, so that will show the length of image. So here I have seen AB is equal to DC. The AB is equal to DC mean what happen? Length of image is equal to किसके होगा बेटा? Length of object. तो in reflecting surface from plane mirror, length of object is equal to length of image. अच्छा, one more thing, if we'll see, after reflection A will reach at point D. A कहाँ पहुंच रहा है बेटा? D पे. And B will reach at point C. तो एक वेव फ्रंट आपका AB है. AB is wave front. ठीक है. A is reaching at D and B is reaching at C. So like that CD will be the new plane wave front. पहले AB wave front था, अभी क्या बना? DC. तो अगर आप ध्यान से देखोगे तो इनिशियल इनकमिंग A will at right, B will at left. अगर आप ऐसे देखोगे तो A कहाँ लाई कर रहा है बेटा? ऑब्जेक्ट जो इनकमिंग ऑब्जेक्ट है A कहाँ पर है? राइट पे, B लेफ्ट पर है. और आफ्टर रिफ्लेक्शन A का रिफ्लेक्शन D है. अब यहां से आप देखो, अगर जैसे हम देखें तो ये हमारा A है राइट, B लेफ्ट, और जैसे यहाँ पर टर्न हुआ तो A कहाँ पहुंचा बेटा? D पे. तो अदर है, इट मीन D बिकम्स लेफ्ट एंड C बिकम्स, जो B पहुंचा C पे तो C बिकम्स राइट. तो इसे आप लेटरल इन्वर्सन को भी आप प्रूव कर सकते हैं कि AB, इफ विल सी वेव फ्रंट, A विल लेफ्ट and B will right. After reflection A will reach at D, B will reach at C. So D at left, C at right. This mean left right. Right का क्या बना? left. तो इससे हम क्या कह सकते हैं कि after reflection there is lateral inversion. ठीक है. जैसे आप देखते भी हो कि P का Q बन जाता है, लेफ्ट हैंड आपको क्या दिखता है बेटा? राइट हैंड दिखता है. तो lateral inversion को भी by the help of wave front we can explain. तो यहाँ पर हमने कई चीजें और भी एक्सप्लेन की कि लेंथ ऑफ ऑब्जेक्ट इज इक्वल टू लेंथ ऑफ इमेज, और एक चीज और भी प्रूफ की, लेटरल इन्वर्सन. ये सारी चीजें जो है हाइजेन ने बाय हेल्प ऑफ प्रिंसिपल, बाय द हेल्प ऑफ कंस्ट्रक्शन ऑफ प्लेन वेव फ्रंट, दे हैव प्रूव्ड.